Hello, Steve here again. In today's video we're going to be looking at clutches. In front of me here I have a pressure plate, a clutch disc and a flywheel. We're going to be looking at these three components and how they make up the clutch system and form a part of the transmission. So, this type of clutch we have here is a diaphragm spring type. We're going to be having a look at this a bit closer and cutting it open to see what's inside it. We are also going to be looking at this clutch disc and cutting it open to have a bit of a better look to get a better understanding of what it is. Okay, so first we're going to look at the clutch disc. So the clutch disc has a friction surface either side. This friction surface binds with the flywheel and the pressure plate. So the clutch disc is essentially sandwiched between the two items. The spring force from the diaphragm clutch cover is what maintains pressure upon the friction surface for it to be able to grip and transfer the power through the clutch. We have some torsional springs, sometimes 3, sometimes 4, sometimes 5. And if the clutch gets bigger, maybe even 6 various springs mounted in the central clutch hub. What these springs do is take up torsional movements. So this clutch hub, as you can see here, there's a line. This splined section in the middle is what would go to our gearbox input shaft. And where it's separated, if you can imagine that your gearbox input shaft would go through this hole, so that would be mounted to your gearbox. This hub, along with the springs, allows torsional movement to allow for a steady uptake of the clutch when the clutch is disengaged and we're then driving the vehicle. The springs help with any sort of vibrations and rocking to smooth out the transmission to give a better ride comfort and quality. Also with the clutch disc, if the camera will pick it up, you can see there are slight gaps between the two friction surfaces. Now as the foot is removed off the clutch pedal and the diaphragm closes up and clamps the disc, there is a slight bit of movement there. And again, that is just for additional cushioning and for a smooth and steady uptake of the clutch. So to be able to show this movement better, I'm going to cut the clutch in a couple of places and remove these springs so I can show you this hub rotating. Right, now I'm going to take this clutch disc and I'm going to make some small cuts in it to be able to release these springs from the clutch disc. Safety first. Okay, so now what I'm going to do, I've relieved some metal from around these torsional springs. So now, it shall come straight out of the clutch disc. So I'm just going to take away this top section now. Okay, so with the springs removed and the rivets removed, we can now lift this section off. And what we can actually see here is we can see the central hub of the clutch disc. As you can see, this piece here rotates. So what you need to remember with this rotating piece is that these springs are mounted in there, and these springs would actually absorb that torsional movement. Okay, so without the springs there, that's the motion that the central part of the clutch will go through to help absorb vibrations and smooth uptake of the clutch. Okay, so what I'm going to do now is I'm going to remove a section of the friction lining material. I'm going to make some very small cuts, and then we should be able to remove it and take a closer look at the springs which are sat underneath. Okay, so with some cuts made in the friction material, I'm now able to remove a section of it. If the camera will pick it up, you might be able to see there are small bits of copper strands inside the friction material. This is inserted in the friction material when it's made to help dissipate heat throughout the clutch. So we can see here we've got our cushion springs, which are a flexible spring steel, and these springs are here to help reduce harshness when you're raising your foot up off the clutch pedal and engaging the clutch and the transmission. It just helps. Without them, it would be quite a solid, impact of the pressure plate hitting the clutch plate and the flywheel together. So these just take up some of that impact force. So now I'm going to have a look at the clutch cover or the pressure plate with the diaphragm spring, and I'm going to see if I can try and separate this surface where the friction face of the clutch disc goes against, and I'm going to see if I can separate it from the cover so we can have a look at the diaphragm spring and how that operates a little bit better. Safety first. Okay, so now I've released the rivets from the check straps on the clutch. I should be able to lift this section apart. Okay, so you can see here we have our thick cast iron part of the pressure plate, which the clutch disc ultimately will go up against, creating friction, okay, and turning with the clutch assembly. So, what I really want to look at is the inside of this diaphragm spring. So, using a hydraulic press, I'm going to show you how when you push your foot down on the clutch pedal, it will force against the thrust bearing, and it will then push against the diaphragm spring, pushing it downwards, which will then lever the diaphragm spring and raise the surface on the inside of the pressure plate away from the clutch disc. And then when we release our foot off the clutch pedal, you'll see now the diaphragm spring returning to shape. What I'm going to do now, so you can understand it, is I'm going to move the camera around to a different angle so we can look at the side of the pressure plate to see how the other end of the diaphragm spring moves with the clutch pedal being pushed and disengaged. So with repositioning the camera, we're now looking side on to the pressure plate. If we notice this here, this is the edge of the diaphragm spring. As we put our foot on the clutch pedal and push the centre of the diaphragm spring, the edge of this plate will lift upwards. And it does that because on the inside of the pressure plate is a pivot point to allow it to move like that. So what I'm going to do now is I'm going to apply some pressure using the press once again to force against the diaphragm spring. As I'm doing this, you may notice that the edge of the diaphragm spring will move upwards ever so slightly. Okay? And with that moving upwards, it's going to move away from the clutch disc, allowing it to spin freely so you can select a gear or change gear. And as soon as you take your foot off the clutch, watch that this will move downwards. And when that happens, the spring pressure is then forced back against the clutch disc, engaging it with the flywheel and driving the transmission. Okay, so from a different angle, looking this time up underneath the pressure plate. So as we put our foot down on the clutch, the force against the diaphragm spring, hopefully from that angle you'll see the spring flatten out and the outside edge start to lift. So then when I release my foot off the clutch, you get that motion go on with the diaphragm spring. So essentially, as you push your foot down on the clutch, we're taking pressure away from the spring, which is allowing our friction disc to spin freely for us to be able to select and engage gears. Okay, so what I'm going to do now is I'm going to try and remove the diaphragm spring away from the rest of the pressure plate assembly, just so we can take a closer look at it. Okay, so I've cut the little retaining pieces away from the inside of this pressure plate, and this is the pivot ring, okay, in which the diaphragm spring pivots over. So now we can remove the diaphragm spring, okay. Probably not got enough strength to push down on it myself. Okay, so that's your diaphragm spring. So hopefully now you can see all the different components of the clutch, all exploded. So all those parts form your pressure plate. You have your friction disc, your clutch disc, and then you have your flywheel. So those three components together form your clutch system and your connection from the engine to the gearbox. One other component of the clutch system which I haven't covered, and I will do in more depth in another video, is the thrust bearing, or the release bearing. The release bearing will be part of the clutch release mechanism, and it will sit on the clutch fork. So as you push on the clutch pedal, it will be forced into the diaphragm spring against the diaphragm spring, releasing pressure and allowing the friction disc to spin freely. And when you take your foot off the pedal, it will move away from the diaphragm spring. So it has a bearing in it, because obviously the clutch and flywheel assembly is rotating very high speed, but the main body of it needs to stay still to engage with the clutch fork. Hopefully you've learned something from this video and learned a little bit more about the clutch system. A lot of people tend to take the clutch system as just being your pressure plate and your clutch disc. There is a lot more to the clutch system. There's a lot more intricate parts which make up the clutch system, so I hope that this bit more of a deep dive today has helped you understand a little bit more about clutches. If you have any questions, then you could get in touch with me via Microsoft Teams if you're one of my students, or if you want to leave me a question on the comments section on this video, I'd be more than happy to answer it for you. Don't forget to like the video, please subscribe if you haven't already, and share the video with others. Just want to add to this as well, it's not a conventional method to cut apart components like this with an angle grinder. I don't recommend you do it yourself. I have many years experience in the trade and I know where the spring pressures are, where to cut, where not to cut. So please don't try this at home, and if you are going to try and do something where you're exploring and removing parts, please do your research first and use the appropriate safety equipment. Thanks for watching.